All right, here we go, Chapter 10 test. Let's bust this out, surface area and volume. So number one, we have a rectangular prism. So I like to just find all the sides that are kind of congruent to each other and put them together. So I'm going to start off with this right and left side. So that's 7 by 4. So we have 28, and we have 2 of those because we have this side over here that matches as well. So that's 56. Then we have this front, which is 9 by 7, and we have 2 of those. We have the front and we have the back. So we have 2 9 by 7s. So 2 63s, which I believe is 126. And then we haven't done the bottom and the top. So the bottom is a 9 by 4. Then we have another 9 by 4. So we have 2 9 by 4s, 2 36s, which is 72. Put all that together. 12, 14, carry the 1, 8, 15, carry the 1. Looks like 254 for the grand total. Volume is a little bit easier. Remember, volume is just the base area times the height. So the base area is a rectangle, which is 36. That's the bottom there. Times the height, which is 7, for a total of 252. All right, moving on to number 2. Go a little further so I can get both of these in this one. So number 2, surface area. Well, we have 2 circles. So we have 2 pi r squareds, 2 circles. That's the bottom and the top. And then the lateral area is 2 pi r h, which is basically just a big rectangle with a circumference and a height. So we just need to plug in the 3 and the 7. So this one is just kind of a plug and chug. And 2 pi 3 times 7. And that shakes out to be 188.5. Putting it all in the calculator. All right, volume. Volume, since this is a cylinder, the volume is just the base area times the height. The base area is a circle. So pi r squared times the height. And that shakes out to be somewhere around 198-ish, depending on if you use 3.14 or use pi, but somewhere in the neighborhood of 198. I think that one was a drop-down menu on the test. All right, the next one. We have a pentagon prism. It's a prism because it has a top and a bottom that are congruent to each other. 2 parallel congruent bases. So for surface area, I have 2 pentagons. All right, that's the top and the bottom. So let's knock that out. Pentagon is 1/2 apothem times perimeter. All right, so let's go through and let's get those pieces. So 2 of them, and they're 1/2. The apothem is 4.1. The perimeter is all the way around. So you have 6, 6, 6, 6, 6. 6 times 5 would be 30. So we got that whole piece, which I think that comes out to be for 2 of those. So that's 123. And then we have the 5 walls. You got your lateral area, which a couple different ways. You could just multiply it by 5 if you want. 5 times, and every wall is a 7 by 6. So 542s, which would be 210, for a grand total of 333. That's the total surface area. Volume's a little easier. Volume is just base area times height. Well, the height of this thing is 7. The base area we've kind of already calculated. That's this piece right here, 1/2 AP. So whatever half of 123 is, I think 61.5. That's the base area. It's the 1/2 AP. You're writing this down. And that comes out to be 430.5. All right, moving right along. Going on to number 4. I'm going to redraw number 4 just because I think it's a little bit helpful. This is not a pyramid. It doesn't all come up to a point. The way it's sitting, it's kind of not a normal prism. If we rotate this and we put this thing to where it looks like this, now I think it's a little bit easier to kind of see what's going on. So this would be our 9. It has a height of 9. And then the pieces inside here, this is a right angle, it said. And these pieces are 6 by 8, and then opposite the right angle is the 10. So we have a 6, 8, 10 triangle. 3, 4, 5's big brother. And now it's a little bit easier to see what's going on. So if we bust out our surface area, we have 2 triangles, okay, which are 2 1/2 base times heights. So let's just do that. 2 1/2. Well, for a right triangle, you could use one of these as the base and the other one as the height. Doesn't really matter which is which because you're multiplying them. So that comes out to be 48. 2 and the 1/2 kind of squash each other. So that takes care of our 2 triangles. Now we have 3 rectangles. And our rectangles are, the front one is 10 by 9. The back side over here is 8 by 9. And then the one over here on this side is 6 by 9, which is 54. And I add all that up, boom, 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 and I end up getting 14, carry the 1, 14, 21, 264. Now you could speed this up by just doing the perimeter times the height. You could add up these 3 numbers and then multiply by 9. It might be faster. I just don't typically do it that way. Well, volume, again, since it's a prism, it's a triangle prism. So since we have a triangle prism, the base area is a triangle times the height of the prism. Well, the base area is, what is this area right here? Well, that's 1/2, 6 times 8. So half of 48 is 24. And then the height of the prism is 9. So 180, 36. We're looking at 216. All right. On to the shed problem. So we have a shed problem. We're trying to find the surface area. So surface area, it's the outer shell. So I have 4 walls and a floor. So that's 5 squares. All right, 5 squares. And then I'm going to have 4 triangles for the roof. So every square, since this is a cube, it's 6 by 6 by 6. So every single face out here is 36. All right. So I have 5 times 36, which is 150 and 30. That's 180. Now my 4 triangles. All right. My triangle is right here. I need to find the area of that triangle. And the area of a triangle. One second. All right, so where was I? Sorry about that. So 4 triangles. So for a triangle, I have 4 times 1/2 base height. And I have the base. The base is 6. So we have 4, 1/2, we have 6. Height is a little bit tricky. All right, so I need this h, and the height is right here, kind of coming down on that edge. So to find the height, I'm actually going to have to construct a little right triangle inside there, inside the house. And I know that one leg is 4. And then since it's right in the middle and it goes to the edge, that should be half of 6. So that's 3. And because of Pythagorean theorem, we know that 3, 4, 5 is a right triangle. You could have also solved 3 squared plus 4 squared equals c squared. I went through that work. But by now, I really need you to understand 3, 4, 5 and 6, 8, 10. Like those two come up so much that they're worth memorizing. So I'm going to put a 5 in here. And 4 times a half is 2. 2 times 30 is 60. So I put 60 in with that. So 180 plus the 60, grand total of 240 for the surface area. Volume is a little bit easier. I kind of cut all this stuff out. Volume is just, you do the volume of the cube plus the volume of the pyramid. All right? So volume of a cube is just the side length squared. So 6 times 6 times 6, length times width times height. These guys. And then the volume of the pyramid, it's a pointy thing. So it's 1/3, 1/3. And then the base area, which the base area is down here, it's 36. And then the height, which is right there, which is 4. And let me clean up that third. It looks a little bit weird. So let me tighten that up a little bit. So 6 times 6 times 6 is 216. 1/3 of 36 is 12. 12 times 4 is 48. So 216 plus 48, that's 266 minus 2, that's 264 for the volume. All right, moving right along. Number 6, the old dunk problem. You're dunking a pyramid into the aquarium. So, and I want to figure out how much the water is going to rise. Well, right now, we can calculate the volume. The volume of this aquarium is going to be length times width times height. So 20 times 17 times 10, which is 2,000 or 200 times 17, 3,400. So right now there's 3,400 cubic inches of water in there. Well, when I put this triangle or this pyramid inside, I'm adding more volume. Well, how much more volume am I adding? I got to kind of figure this one out. So volume of a pyramid is 1/3 base area, which is 12 times 12, times height, which is 9. 1/3 of 9 is 3. 3 1/44s is 420 plus 12, I think, 432. 432. So when I add 432 into this, I now have a new volume. My new volume is 3,832, has to fit inside of this aquarium. Well, the aquarium is going to hold, this is still going to be the length. This is still going to be the width. We're not changing the size of the aquarium. What is going to change is H. So let's work it out. So we know that volume is length times width times height. We now know how much volume is going to be in there. 3832. The length is 20. The width is 17. The height, we don't know. So I crank this out. 3832 equals 340 H. And divide both sides by 340. 340. And when I put that in the calculator, I got 11.127. Now it used to be 10. Now it's 11.127. Or correct that. 11.27. So it actually went up. It rose 1.27 inches, which we probably rounded it just to 1.3. But that was a drop down. That was kind of a tougher problem, similar to what was on the review. Last one, we have an aquarium. We're dumping cones into there, trying to see how many cones it'll take to fill it up. So not too bad. So first we need the volume of this guy, which is 24 times 12 times 16. And when I multiplied all that out, I believe I got 4608 cubic inches. So that's the volume of the aquarium. The volume of the cone, since it's a pointy thing, it's 1/3 base area times height, which is 1/3 pi r squared times the height. And punching all this stuff in, this came out to be like roughly 20.9-ish. So this was 20.9. This was 46 0.08. And now we want to figure out how many of these does it take to go into there. So it's a division problem. You actually divide the bigger number by the smaller number. And I think we come out somewhere in the neighborhood of 220, 221. A lot of it depends on if you use pi or 3.14. But again, this was a drop down, so it shouldn't have been a big deal. All right, hopefully this video helped you out and explained things step by step. See you.